Hi, hello, a very good evening. Welcome to my YouTube channel. So, today we are going to talk about how to store sensory data on blockchain network. It was very nice meeting all of you in this webinar. So, thank you for joining me today. In this webinar, we are going to discuss about how to store IoT sensory device data on blockchain network. So, a warm welcome all of you. And today we will be discussing about how to create a smart contract for IoT devices, how to differentiate a trusted device and non-trusted device, or authorized device or non-authorized device. I'll be showing you the entire complete end-to-end process of this project, where I'll be creating some smart contracts. So I'll be deploying that smart contracts onto the blockchain network. I'll be using crypto wallets. So I'll be using blockchain servers. So everything I'll tell you in detail from scratch. So let us jump into this webinar, and again a warm welcome to all of you for this complete end-to-end project on blockchain network. So before we get in, let me introduce myself. My name is Madhu Parvatneni. People call me as Maddy. I'm IoT blockchain machine learning domain expert. I used to work at Madblocks Technologies as a solution architect, and this is my LinkedIn URL. If you have any questions to ask, or if you want to need my guidance for your project, you're warm welcome, and you can send me a message on LinkedIn. So this is my QR code of my LinkedIn profile. You can quickly scan this. It will take you to my LinkedIn profile. You can stay connected with me on that. Okay. So let me tell you one important thing. We are creating this kind of webinar series to share knowledge, so that you could develop some kind of innovations in college campuses with the help of these kind of concepts, so that innovation is a new invention. So if you want to start your company or venture, obviously there should be some kind of innovation in the project. So all this technical stuff will be helping you out in delivering that kind of things at college level. So, and there are more events lined up in my YouTube channel, so you can get the live updates through this Telegram group. You can join this Telegram group and you can interact with me. Say if you are watching this video later, if you have any question to ask, or if you get any error, or if you want my suggestion in implementing this project much better, you can reach out to me on Telegram group also. Okay, this is a Telegram group. You can quickly scan this QR code and you can join the Telegram group. Okay, so for better communication. So without any further delay, let me talk about how to create this project called storing sensory feed on blockchain network. So the main objective of this project is to store the sensory feed in an Ethereum blockchain network using smart contracts. So I'll be writing a smart contract to store the sensory feed on blockchain network. I'll show you end to end how to create a smart contract, how to deploy the smart contract, and how to interact with smart contract, how IoT devices interact with smart contracts and all that. So you'll gain some knowledge. And if you want to get a e-certificate, you can quickly click on the link which is given in the YouTube video description. You can become a paid subscriber. You'll get e-certificate. And if you want to become a project subscriber, you can reach out to me on LinkedIn. You'll get complete end-to-end kit and also a certificate. So this is a complete intro related to the webinar which we are going to start now. So any project you take, I always talk about block diagram, because block diagram is very important for developer to understand where to start the project. So say if you want to define a project or if you want to start your project, you should understand what is the complete outline of the project. So here today in this webinar, I'm going to talk about how to create a project on blockchain, where that project, what it will do, it will store the sensory feed on blockchain network. So if you want to store the sensory feed, obviously you need a sensor. So sensor which I'm taking now is DHT11 sensor. So DHT11 sensor is nothing but a humidity temperature sensor, where it will be monitoring humidity and temperature values, and that humidity and temperature values we are passing to a microcontroller unit. So this is a microcontroller unit which is nothing called Arduino. So this is very popular in terms of IoT communities. So if you want to create some kind of IoT projects, you can also look at this kind of controller, which is like Arduino. Arduino is a microcontroller where it will be used to read the data from the sensor. So this is a sensor. This is nothing but DHT. This is nothing but DHT11. Okay, so this is nothing but DHT11. Okay, DHT11 sensor, which will be interfacing with a microcontroller, which is like Arduino. So Arduino is a microcontroller, so where it will read the data from the sensor, and that data it will pass to Python script. And what this Python script will do is, Python script will be able to create a bridge between the microcontroller and smart contract. As I said, if you want to interact with blockchain, if you have a basic knowledge on blockchain, you could able to understand this. If you want to interact with blockchain, obviously you need a smart contract, and this smart contract cannot interface directly with microcontroller. So there should be some kind of scripting language, because smart contract which will be deployed on blockchain server, if you need some kind of programming language which interact with server, you need a scripting language, and Python is a scripting language where it can able to easily communicate with the blockchain server to the smart contract. So here, that is why what we'll do is we'll pass the sensory data to Python, and what Python will do, Python will able to send this data to smart contract, and the smart contract, smart contract is a self-executable program, where it will understand what the data it is received from Python. So based on that, it will do, if the data holds sensory data, whatever the feed which is coming from Python script, that data will be appended to the block, and that block will be added to the blockchain, and that blockchain will be updated in the Ganache. So you will have a ledger, so that ledger will keep updating for every sensory feed that comes from Python script to the smart contract. And here there will be two types of devices. So one is like trusted device, second one is untrusted device, or you can say non-trusted devices there, or authorized device, non-authorized device. So that is why whatever we have to do is, if you want to publish the data from sensory unit to the smart contract, make sure that that device is added to the blockchain network, then only it could able to transfer the data. Because if the device is not trusted, you could not upload data to block, right? So you have to upload data to the block only when device is trusted. So you have to understand that which device is trusted, which device is not trusted. You should able to differentiate a trusted device and a non-trusted device, or authorized device and non-authorized device, because you cannot simply upload the data whatever the data comes to you. You should upload the data only when it is from a trusted device. So that kind of differentiation also I'll show you in this webinar. Okay, how to create a device policy, how the smart contract will able to identify which device is trusted, which device is not trusted. So that kind of logics also I'll be showing you, so that you could develop your own project on blockchain to store the sensory data. So this is a complete outline. So I'll start from scratch so that you could able to understand. And let us talk about the prerequisites. The important prerequisites are, you should have a basic knowledge on Python programming, because we will be using Python script in order to communicate with smart contract. And also you should have a basic knowledge on blockchain. You should understand what is Genesis block, what is Ganache. I have also made some tutorials on this. You could check out the blockchain bootcamp playlist or blockchain playlist. You could able to find some tutorials on blockchain. So if you watch the tutorials, it will be helping you to understand this kind of terminologies here, because you'll understand certain because there will be some certain process which I will do in the next 1.5 hours. you'll understand all that, if you could able to have some basic knowledge on blockchain. I'll be using some kinds of software called Ganache. Ganache is nothing but local blockchain network. So this I'll be using it to deploy my blockchain smart contracts and all that. And I'll be using a framework called Truffle. So Truffle is nothing but a framework which I will be using to create smart contract. And Node.js is nothing but I'll be using Node.js to run a web server, because I have to create some kind of user interface. So using that user interface, I should able to receive data, what are the data that is being stored on the blockchain network and all that. So I need some kind of Node.js. Along with that, I need MetaMask. MetaMask is nothing but crypto wallet. So I need a crypto wallet to make interactions with the blockchain network. So this also I need. So I'll show you some basic steps in related to this. And also you could able to watch my videos which are there on my YouTube channel on blockchain, so that you can able to understand how to install Truffle, how to install Node.js, how to install MetaMask and all that. I have given you basic outline on this tools in my blockchain playlist. You could able to watch those videos also to understand much better on this. Okay, so let me jump to the next slide. So what are the libraries needed? So here, to develop this project, we need Truffle. Truffle is very, very important. You should able to install this Truffle earlier. Otherwise, during the live project implementation, there should be Truffle installed on your machine. I have installed this Truffle earlier on my laptop. So my laptop has Truffle, my laptop has Ganache, my laptop has Node.js, my laptop has Arduino software. So Arduino software is also required to program Arduino hardware. So I have all these softwares installed on my laptop. So in this webinar video, I'm not able to show you all quick installations, but I have recorded some videos also. So they are there in the YouTube channel. You could watch those videos to understand how to install these tools. Okay. So let me talk about the quick project structure. So what is a project structure that I'm going to create? So I'm going to create 7 kind of files or folders. So let us talk about the first file. And the first file is nothing but package.json. Package.json is nothing but a that's a JSON document where it will be having what kind of packages that npm has to install. So node package manager has to install. So all that will be included in the package.json. And also I will be creating one more file called bs-config.json. So bs-config.json is nothing but a JSON document. So this is required for a web server to understand where are the smart contracts and where are the HTML files, because always web server has to reallocate the HTML files, right? It has to reload all the HTML files. So in the bs-config.json we will be telling that where are the contract files and where are the HTML files. So I'll show you how to create this JSON documents also. And the third folder is contracts folder. So contracts folder is nothing but in this folder we will be writing all contracts related to the project. And migration is nothing but this is also a folder where it holds all the migration scripts related to the project. And we will be having src folder, source folder. This is nothing but a main important folder where it holds all HTML files, JavaScript files related to the project. And test is nothing but a folder which testers will be writing some kind of test scripts. So in order to check the project, so they'll be writing all that scripts in this test folder. And finally you will have build/contracts. Build/contracts is nothing but a folder which generates the build of the contract file. So this will be stored in build/contract. The compiler will be there. The Solidity compiler will be there. And the Solidity compiler will be compiling the smart contract, and the build file will be stored in build/contracts. So this is a simple project structure which I will be creating in the next few minutes. So like that is why I wanted to tell you that what is the each and every important file and folder that I'm going to create. So don't worry much about this. I'll be showing you each and everything in detail. So let's talk about stages of development. So there are 8 stages of development. So I'll be dividing this project into different stages for easy development. And the first stage is connect hardware. So we have to connect DHT11 sensor with Arduino, and Arduino we have to program the Arduino so that the hardware program will be publishing the sensory data to the Python script. But before that we have to initialize the Truffle. So whenever we initialize the Truffle, then only the smart contracts and everything, the project template will be created. So once a project template is created, we can create a smart contract. So once a smart contract is created, we can able to compile and migrate to the blockchain network. Once it is compiled and migrated, we can able to create a Python script, so that this hardware will be sending data to Python script. And after that, we can able to add this device to the blockchain network, so that we can make the devices trusted, and then we can able to store the sensory feed on the blockchain network. So these are the 8 different phases. Okay, this is not the program flow, this is the 8 different phases of blockchain project, so which I'm going to create now. Okay, hope you have understood how I am breaking this project into 8 different phases. Okay, so first we have to connect hardware, second we have to program the hardware, and third we have to initialize the truffle, and fourth we have to create a smart contract, and fifth we have to compile and migrate to the smart contract to the blockchain network, and we have to create a Python script so that hardware can able to receive the data. The Python script can able to receive the hardware data, and we have to add this device to the blockchain network, and we have to store the sensory feed on the blockchain. So this is a simple divide and rule stages, where we have to divide them, so that we can able to program it one by one. Okay, so let me start the process. Okay, in this webinar video I'll be showing you each and everything in detail. Okay, if you get any question related to this project implementation, you can drop a comment to this video, or you can also send a message in the Telegram group. I will be quickly answering that. Okay. So before we get in, let us understand what is smart contract. Okay, smart contract is a self-executable program which runs on Ethereum blockchain network. So the main important thing is that if you want to interact with blockchain, so blockchain is a server which is having distributed ledger process. So we cannot directly interact with blockchain network. What we have to do, we have to we have to create a smart contract, and that smart contract is a self-executable program which will be deployed on the blockchain network, and we have to communicate with smart contract. And smart contract is as it is self-executable program, it will execute the logic which is written based on the business problem what we take. And the benefits of using smart contract is that there is no this is a paper free process, and it is very efficient than the general third party brokerage. So as it is eradicating the third party, obviously it will be having a speed and also which is very secure, because we will be deploying it on the blockchain network, and always smart contract will have a clear cut process, because this is a simple, we will be creating some kind of rules in the smart contract, so that whenever the conditions are met, then obviously the process will run automatically. Okay, so I have given in detail discussion about smart contracts in my blockchain playlist. You could watch that, so that you will be understanding much better knowledge on smart contracts. Okay, so now the main agenda of this webinar is to show you this project. So let me start the process. So I'll start with hardware. Okay, so I have to create hardware, but before that I'll show you how to launch Ganache. Okay, so let me click on Windows button. So let me search for a software called Ganache. Okay, so Ganache is a blockchain server. You can download it from Google also. So I have shown this installation process in another video. You could watch that video. Okay, so that you'll understand how to download Ganache, how to install it. But as of now I'm just opening that. So Ganache, so I'm opening the Ganache. Ganache is a local blockchain server. So Ganache is open. Now what we have to do is we have to create a workspace. Okay, so that we can able to generate we could able to deploy the smart contracts, and we could able to store the sensory feed on this Ganache. So by using Ganache platform, you could able to create launch a blockchain server. So here you will have quick start and new workspace. You can click on quick start, so that immediately, as it is Ethereum was selected here, it will immediately launch Ethereum blockchain server. So what Ganache will do is Ganache will launch the Ethereum local blockchain server. Once the server is launched, it indirectly means that Genesis block is created. So the first block will be created by the Ganache, and later on we can able to add the blocks based on the application context. Now you can able to see block 0 is added. So block 0 is added. This is nothing but the Genesis block which is already added, and we have different accounts here. So these are the test accounts. So you can able to use this accounts, okay, for IoT devices here in this context. And now you could able to understand that this server is running on 127.0.0.1 colon 7545. So this is the IP address 127.0.0.1, which is nothing but local IP address, and port number is nothing but 7545. So we have IP address and port number. So this is nothing but the blockchain server. So here you can able to see different types of accounts. So these are the local accounts where you can able to see the account balance of each account is 100 ethers. So that these are like test ethers, okay. So this is like a test network, and you can use this accounts for transactions, okay. So now what I'll do is I will add the MetaMask to my Google Chrome, okay, so that I could able to use that MetaMask as my crypto wallet. So my Ganache server is running, so I'll just minimize this, okay. Now I will just open the Google Chrome, okay. I'll open Google Chrome, and here what I'll do is I'll just install the MetaMask extension. So if you want to install the extension part, you have to click on the vertical ellipsis, and you have to click on extensions, or you can click on what is this, okay, settings. You can able to see the extensions here, okay. So you have to click on that extensions, and after that you have to go to web store, okay, Chrome web store, and here in the Chrome web store you can search for MetaMask. Okay, you can search for MetaMask. Immediately you can able to get the MetaMask extension, okay. Let me add to Chrome, so that the MetaMask extension will be added to Chrome. So MetaMask is nothing but a crypto wallet. So it will be connected with my local blockchain network, which is Ganache. So brief explanation about MetaMask I have given in the video. You can check that video. As of now I'm just focusing on project, okay. So MetaMask is added to Chrome. Let me click on get started. So when I click on get started, you'll get new to MetaMask. If you have already a recovery phrase, you can select that, or else you can create a wallet. Now let me click on create a wallet. So let me click on I agree. So let me create some password. You can keep a random password, okay, don't forget the password. And let me select the agreement. So this is a generic agreement, nothing to focus. Let me click on create, so that the MetaMask will be created, account will be created, and now we will be getting the secret phrase. So generally what we have to do is we have to store the secret phrase, okay. So this is a secret phrase, we have to store it in a safe place, okay. This is very important. And let me select the agreement. So okay, let me put it in a safe place, okay. So I'm just saying that, okay. So let me click on next, and now we have to enter the same phrase, okay. Mine is quiz. I have to enter the same phrase which has been shown in the previous page, okay. So quiz, anger, crawl, lava, round, final, funny, thought, blast, mistake, nodal, and cause. So this is how you need to arrange your words, okay. Arrange your seeds so that it will convert into a secret phrase. So let me click on confirm. So my all things are done. So it is saying we have to click on all done. So it is saying that everything is ready, okay. Now the MetaMask wallet is added to the Google Chrome, okay. Okay, let me pin it. So now what I'll do is I'll create a network, okay. I'll click on this, okay. So there is a drop down, so I'll click on that. So it is showing Ethereum mainnet, okay. So Ethereum mainnet, you need real money to make some transactions. So that is what I'll do. I'll click on add network. So here let me have a name called local Ganache, Okay, RPC URL, you have to enter the blockchain server IP address and port number, http colon 127.0.0.1 colon 7545. Okay, so that was the IP address and port number. Chain ID. Chain ID for Ganesh is 0x539. Okay, I'll be entering the same thing. Okay. Okay, it is saying that it is already in use. Okay. Okay, let me give 1, 2, 3 so that it will tell what is ID. Okay, let me click on save. So it is saying 0x539 only. So generally 0x539 is the default. Okay. So let me click on save. Okay, so it was now connected to local Ganesh. Okay. Now here what we have to do is we have to take one account from the Ganesh. Okay. So say you have 10 different addresses. I'll take the first account. Okay, this is the first account. So this is the address of the wallet. Okay, and the balance is 100 ethers. Now there is a secret key here, which is a private key. What I'll do is I'll just click on this key icon. So it will show you the private key of this account. Now what I'll do is I'll just copy this private key. I'll just import this account into the MetaMask. Okay. So here it is 0 ethers. For 0 ethers you cannot make any transactions, right? So that is why I'm just importing the account. You have to click on this user icon. So you'll get import account. So you have to click on import account. Now here you have to paste the private key. So when you click on import, immediately you could able to see that your account is having 100 ethers. So when your wallet is having 100 ethers, okay, then only you can make transactions. Not only 100 ethers, greater than 0. So always greater than 0, so that you can able to make some transactions. Okay, so you can make transactions only when you have some money in the wallet, right? So that is why what I did here, I have imported the first account. Okay, like this you can import any account from here. Okay, so I have imported the first account. So how to import the account? You have to click on the a key icon. So it will show you the private key, and you have to copy the private key here, and you have to paste it here. When you click on import account, it will show you private key field. You have to paste it here. So this is how you need to import your account. Okay, now the account was imported, MetaMask is ready. Okay, the Ganesh is launched. So Ganesh server is also running on my machine. MetaMask is also ready. So let me create let me connect sensor with Arduino. Okay, so I'm using DHT11 sensor. DHT11 sensor generally has 3 pins: VCC, ground, and data. So let me connect VCC with 5 volts, ground with, you can take any sensor. Okay, but the sensor is not so much important. Okay, because I have taken humidity and temperature sensor. You can take any other sensor which is available with you. Okay, this sensor has humidity and temperature. Okay, so I just wanted to store this humidity and temperature in the blockchain network. You can take any sensor. Okay, I have this sensor with me, so I have connected. Let me open Arduino software. I have Arduino software on my machine. So let me open Arduino software. Okay, so this is Arduino software. Let me write program. So let me include the header file. Okay, so then we need an header file called DHT because I'm using a sensor called DHT11. Okay, I'm using a sensor called DHT11. The programming language was embedded C++ in Arduino IDE. So I have included header file. Okay, which is hash include dht.h. After including header file, every header file in embedded C++ is a class. So we have to create an object for it. And to create an object, you have to write class name and object name, and we have to pass certain parameters here. And the parameters are to which pin it is connected. It is connected to pin number 3 on my circuit. Okay, so it differs from sensor to sensor. Okay, I'm using DHT11 sensor. You can use a different sensor which is available with you. It is based on the sensor which you connect. Okay, so this program is for DHT11 sensor. Okay, 3 comma and the name of the sensor is DHT11. Okay, so you can search in Google also, get all the data related to it. DHT space DHT3 comma DHT11. 3 is nothing but pin number to which pin DHT11 sensor is connected, and what is the type of sensor. Okay, so all this we have to create. Okay, so you will have two functions in Arduino. One is void setup and second one is void loop. So in void setup, what I'll do is I'll just simply initialize the serial port, okay, to monitor the data. Serial dot begin of 115200. So that is the speed of the serial communication, and we have to begin the DHT sensor communication so that the sensor will able to push the data called humidity and temperature. Now let us read the data in void loop. Okay, so let me read the data. So humidity value, say float humidity equal to DHT dot read humidity. So we have to read the humidity value, and also we have to read the temperature value, DHT dot read temperature. Okay, so DHT dot read humidity is nothing but a logic which reads humidity value from sensor. DHT dot read temperature is nothing but which reads the temperature value and stores that value in temp variable. So all this are hardware scripts. Okay, so if you are good at hardware, you can able to understand all this. Okay, that is why if you want to do this project, you make a team. Okay, a team of hardware engineer or hardware electronic student and a computer science student, so that the electronic student can able to write this program, so that it will help you out. Okay, or you have to go through the Arduino software, Arduino hardware, and this kind of logics you have to practice. Okay, so as of now we are reading humidity value and temperature value. So if these values are none, okay, so if these values are none, we cannot able to push the data to Ethereum blockchain network. That is why we have to check whether these values are none or not. If they are none, then immediately we have to return back. Okay, if they are not none, then only we have to pass this data to the blockchain network. So that kind of logic we have to create. So serial.print of humidity. So what is the humidity value? We have to print here. And what is the temperature value? That also we have to print. Okay, so that we can able to understand. Delay of 4000. Okay, let me save this program. So I have saved all these files. Okay, so a GitHub repository is already created. I have uploaded all these files to my GitHub profile that is given in the YouTube video description. You can able to click that, you can get this code. Okay, don't worry about the programs because all programs have been shared. So let me upload this program. So you have to click on right arrow. So then immediately this program will be uploaded to Arduino. And what Arduino will do, Arduino will be able to read the humidity value and temperature value. Let me open the serial monitor. Serial monitor will be here. So you can able to okay, so I guess lost. I have given us print. Let me give print ln. Okay, so that it prints in a new line. Let me upload the data again. Yes, so you could able to see that the humidity value is 68.00, temperature value is 29.00. Now what I'll do is, instead of sending all this, okay, I'll send a simple thing. Okay, so I'll send something like this: serial.print of hash. Okay, after that I'll append a comma, and then I'll write humidity value. Okay, and then comma again, so which is like one kind of format. Okay, so that the Python script can able to understand. Print comma and serial.println of negation. Okay, so which is like end of the format. Okay, instead of sending this like this, okay, I'll be sending in some format. Okay, so let me put comment for this. Okay, this is a multi-line comment. Okay, so let me upload the program. Now what you have to do, what you have to get is you have to get something like hash humidity value Yeah, hash comma humidity value comma temperature value comma negation. So this is the format which I'm using now. So I'll pass the same data to Python script. Okay, and this humidity value and temperature value, what should happen? So this data has to be stored on blockchain network. Okay, I'm not using any kind of database, I'm not using any kind of IoT cloud, I'm using a simple blockchain network to store this data. Okay, so this is my hardware program. I have shared this in my GitHub repository. You can download this code from there. Okay, so the repository link is given in the YouTube video description. Okay, all right, so let me so my hardware program is done. Okay, MetaMask is ready, Ganache is ready, and this is also ready. Okay, so let me go back and look at the software development. Okay, so this is ready, right? So this is ready. We have programmed the hardware. So next we have to initialize the truffle, right? So let us initialize the truffle. So to initialize the truffle, what I'll do is I'll create a folder on my desktop. Okay, let me create a folder on my desktop. Okay, new and folder. So what I'll do is I'll write YouTube live. Okay, YouTube live IoT feed. Okay, something like that. So here in this folder, I'll initialize the truffle. Okay, so let me open VS Code. Okay, so VS Code is very popular platform to create some programs and projects, right? So I'll be using VS Code. Let me click on file and open folder. So let me go to the working directory, so which I've created. Let me click on desktop. Let me select that folder which is YouTube IoT live feed. Okay, so Node.js is installed, npm is installed on my machine. Okay, Ganache is installed, MetaMask is also there, and Truffle is also installed. Let me initialize the Truffle project. Okay, so let me initialize it. Okay, so to initialize it, if you want to check the version, okay, so whether it is installed or not, you can type truffle space version. So when you hit enter, it has to display the details of the truffle. Okay, so it is saying that truffle of version 5.4 is installed, and Solidity is a programming language to create smart contract, and that is also installed. Solidity compiler is also installed of 0.5.16, and Node.js is installed 6.13.1, and WebJS is also web3.js. So this is the main important JavaScript library to interact with smart contracts from the HTML. So that is also installed. Now here let me initialize Truffle. Okay, so Truffle space init. So when you type Truffle space init, immediately you could able to see this. Okay, contracts, migration, test folders are created, and truffle-config.js is created. The remaining folders and files we have to create manually. Okay, so now the contract folder is created. In this contract folder, you can store the contracts. In migrations folder, you could able to store the migrations. Okay, and in test folder, you can able to store the test scripts. Okay, if you want to test your project. Okay, so now, so we have initialized Truffle. Let us write smart contract. Okay, so let me click on, so you have to select contracts folder. Inside contracts folder, you have to create a contract called device.sol. Okay, the smart contract, I'm using Solidity programming language, so the extension should be .sol. Okay, so let me hit enter, so that the Solidity file is created. Now here what I have to do is I have to write program of my smart contract. Okay, what the smart contract has to do? The smart contract has to store the sensory data on blockchain network. Okay, so let me tell which compiler version it has to take. So pragma solidity space 0.5.16. okay, oh, it is saying 0.8.11 is installed. Okay, let me do one thing. Let me put something like exclusive ORs 0.8.11. Okay, so that so any compiler which is greater than 0.8.11 can able to compile this program. Okay, so let me create a contract space device. So I'm creating a contract called device. So here what I wanted to do is I wanted to have some contract in such a way that there are a lot of things has to be done here. Let me create a function add device. So what I have to do is I wanted to add a device, okay, because we have to list out all the trusted devices, right? So let me put public mode, public access, so that the outside people can able to access this function add device. And also let me create one more function called view devices. Okay, so view devices public. Okay, so this is one more function which is nothing but it is displaying which devices are added. Okay, so here what I will do is I'll simply store the address of each device. Okay, I'll take a data type called address array, and I'll store something like device address. Okay, and also every device I'll store the device address and I'll store the mobile number of the owner. So what I'll do is I'll take bytes 32. This is also allocate 32 bytes of data. So bytes 32 array, I'll write mobile owner. So mobile owner is nothing but a variable which we can use it. So what indirectly means that the while registering the device we have to enter the device address and mobile number, and that details will be added to the smart contract, so that it will become a trusted device. It is like device registration. Okay, so when you're registering a device to the blockchain, when you're adding a device to the blockchain network, you have to provide the mobile number of the owner and also device address, so that it will register on blockchain and it will make it trusted. So here what I'll do is I'll simply create I'll create a boolean variable. Okay, so mapping address. Okay, if this address is mapped, I'll be mapped to bool public devices. Okay, so that if there is any device, so what I'll do is if the address is already there in the list, okay, I'll make it true. If not, I'll make it false. Okay, some kind of mapping I have recorded here. Okay, so now what I'll do is simply I'll take one variable, okay, which is like byte 32, because I have to pass the owner. Okay, so I'll write mobile owner. Okay, which means the mobile number of the owner. Okay, so if this mobile number is not available, okay, it is not available, then require is to check whether this available or not. Devices of message.sender. Message.sender is nothing but the person who calls the smart contract. Okay, so that will be checked, verified whether that address is there in the device or not. If that address is not there, so this will return false. Okay, so not false is nothing but true. So immediately this will allow the execution here. Okay, so thereby not false is nothing but true. So thereby initially no address will be there in the array, so there will be no address in the array, so that so this will become false. Not false is nothing but true. Now what I have to do is I have to add this. Okay, devices of message.sender. What I'll make true. Okay, which indirectly means that it is already configured. Okay, so here what I'll do, I'll push the device address, okay, to device addr, so device address is nothing but the person who is calling the smart contract. So the device which calls the smart contract will be nothing but message.sender. Okay, so that I'll be pushing into the device address, and mobile number also I'll be pushing mobile owner dot push of mobile number, which is nothing but m owner. So that will be also pushed, so that the mobile owner will be pushed to mobile owner and device address will be pushed to device addr. So that device address is being stored and mobile number is also stored. Okay, so let me so this function is completed. So what this function will do, this function is nothing but adding device to the blockchain, so that device will become trusted. Okay, so only the trusted device has to call the the remaining functions. Okay, so this, whenever the device is added, that device can only send data to the blockchain network. Okay, so next, let us create a function called view devices, say which device is been added. Okay, so what I'll do here is, like, I'll return the device addr, okay, and the mobile owner. Okay, since it has written, now we have to write returns of address. So device address is nothing but address data type, and since it is dynamic, we have to write memory keyword, and mobile number is of byte 32 data type, and it is also dynamic, so we have to provide memory keyword here. Okay, so that it will return the device address and mobile owner. Okay, since it is not doing any kind of operation, we have to put view access only. Okay, so public view returns memory address and mobile number. Okay, so it is returning device address and mobile number of the devices which has already added. So this is to list out which devices are added, so this is the second function which I'll be writing here. So let me save this. Now let us jump to two other functions. Okay, and the first function is, let us write a function to store the sensory feed. Okay, so function store feed. Okay, so let us give some data type byte 32 humidity, because we wanted to store humidity value and temperature value, right? So we have to create a smart contract for humidity and temperature. Bytes 32 humidity, bytes 32 temp. Okay, so we have to create two variables here. So let me put it public so that the Python script can able to access. Now here what we have to do, we have to create some variables. Okay, say something like, I'll create a structure. Okay, so struct is a keyword in Solidity. Struct space IoT feed. Okay, and bytes 32 humidity, bytes 32 temperature value, and who is the owner of this data. Okay, so user ID. So I'll be creating a structure. I'll create a structure array. Okay, which is like IoT feed square bracket, which is structure array. I'll write something like sensor feed. Okay, so sensor feed. So this is a structure because here we have to understand which device is sending this, right? Humidity, temperature, and user ID, which is nothing but device ID. Okay, so or you can write it as device ID also. Instead of user ID, you can write it as device ID also. Okay, this is nothing but device ID. Okay, now let me have some logic here. Okay, so let me check whether it is trusted device or not. Okay, before we store the data, we have to check whether it is trusted or not. How to check trusted or not? Using require if this address is already available. Okay, if require of devices of message.sender, if this address is already available, what will it happen? It will return true. Okay, if it returns true, then only it will allow the execution. Okay, otherwise it will not allow the execution. If the address is not available in the trusted devices, okay, if the address is not available in the trusted devices list, it will not allow. So here what we have to do is we have to store the data. Okay, we have to create a temporary variable for structure. So IoT feed space memory new underscore feed. So this is a new structure variable which I'm creating. So IoT feed of humidity, temperature, and the address message.sender. So that is nothing but address. So this new underscore feed I have to push to sensor feed. Okay, dot push of new underscore feed, so that to that structure array, so this new feed will be added. Okay, so what this function will do, what is the main agenda of this function? This function is to store the sensory feed, okay, into the structure. So where is that structure? The structure is there in the smart contract. Okay, so in the smart contract memory of the blockchain, so this structure will be stored. And then we have to write one more function to display this data, right? Function view feed. So we have to call public So we have to return the sensory feed, right? So we have to use public returns, public returns. So what we are returning, we are returning humidity value, okay, and also we are returning temperature value. So we have to write two arrays here, okay. So now what I'll do is I'll display the only owner's data, okay. I'll display only one particular user data based on the address, okay. So require if that data device address is there in the devices, okay. So I'm checking whether it is a trusted device, trusted request or not. If it is a trusted request, I can able to check by using this, right? So if this returns true, it means it is a trusted device, okay. And here what I'll do is I'll just have a for logic for I'll use an iterative variable unsigned int I equal to 0, I less than sensor feed dot length I plus plus, okay, sensor feed dot length, okay. So this is case sensitive. Now here what we have to do is if sensor feed of I, if this address, so I given user ID, right? User ID double equal to message dot sender. If that user ID is equal to the device address, okay, message dot sender is nothing but device address here. If the user ID and device address are equal, then only we have to push, okay. So let me take two variables, okay. Let me take two variables here. So I'll take two variable bytes 32 h and bytes 32 array t, which is humidity and temperature. So what I'll do is I'll simply push this data, okay. So I'll just push the data, okay. So h dot push of sensor feed of I dot humidity value, and also I'll push t dot push of sensor feed of I dot temp. So the humidity value and dot operator, you know, structure members are accessed with dot operator, right? Isn't it? Now let me have view access, okay, because we are not doing anything, we're just reading the data. So when we are reading the data, we have to pass, okay. Acha, here we are doing this, right? So we are pushing the data, we are updating the humidity array, right? So that is why we have to miss this, okay. So what it is saying, okay, we are not returning anything else, okay. Now let me return after this for loop, let me return h comma t, okay, which is humidity array and temperature array. So this data will be returned to the user, okay, based on the request. So if they make this function call, so if they call this contract function, so these are nothing but contract functions, okay. So what is this function? So this function is to view the sensory data, okay, whether it is stored or not. So what it will do, it will return the humidity and temperature data of only one device, okay. So based on the device address, okay. Now here what I'll do is, okay, now what I'll do is I'll simply compile this contract, okay. So to compile the contract, truffle space compile. So this is the syntax to compile the smart contracts, okay. So truffle space compile, it will compile, okay. There is some problem, let me check it out, okay. Okay, 0.8.10. Okay, let me compile it again. Okay, it is related to the version. Alright, the contract was compiled successfully. You can able to see compiled successfully. Okay, now let me look at the migration script, okay. So we have to create a migration script now. So the contract was compiled successfully, there is no error in the contract. I have shared all these programs in the I have shared this program in the GitHub repository, okay. You could able to get that. Okay, so the repository link is there in the video description. You can download it from there. Okay, so now the smart contract was created. Now what we have to do, is we have to uh, create a migration script, right? So let us go to migrations folder. So in migrations folder, let us create a script, okay, which is like to underscore deploy device.js. So migration script, always it should be JavaScript file, okay. So let me click on JS. So here we have to create a migration script so that whenever we migrate this contract, so this contract will be migrated onto the blockchain network. So here const, let me take a const variable, const device equal to artifact. So whenever you compile the smart contract, okay, artifact will be will be generated in the build contracts folder. In the build contracts folder, if you see device.json, this is called artifact. So this will be generated automatically based on the Solidity compiler. Okay, if there is no error, then immediately this artifact will be created. Okay, so the name of the JSON document is device. Now the I've created a variable called device, and I just wanted to export this onto the blockchain network. So function of deployer, let me deploy this deployer.deploy of device, so that this will be deployed onto the blockchain network. Let me call a command called truffle space migrate. So truffle space migrate is nothing but which migrates this entire smart contract onto the blockchain network, so that so everything was set. So you could able to wait for a minute, so that this will be now on the blockchain. If you see, there is only one block right now. The contract will be migrated, so that you could able to see multiple blocks added. Okay, now the multiple blocks are added, which means that your smart contract is migrated onto the blockchain network. Now here you could able to check out the contract address. Okay, so there will be a contract address. This is very important. Okay, so this is a contract address for our contract which is created, because in the Python script we should able to handle this. Okay, so here also it will display what is the contract address. The contract address for device is 0xC74. Okay, so that is the same contract address where you can able to see it out here. Now the contract address is created. Now what we have to do is we have to jump into the front end part. So front end is nothing but we have to create some HTML files. Okay, let me create a source folder here. Okay, so let me create a source folder, so that in the source folder I can able to have some HTML files. For time being, what I'll do is I'll just download this from my GitHub. So in my GitHub you could able to have some repository called boiler template. Let me get the templates here. So github.com/madblocksgit, this is already there in my video description. Okay, you can able to watch that. So in repositories, so we'll have this boiler template. Okay, IoT blockchain boiler template. So now what I'll do is I'll just download all these files. Okay, I'll just copy the repository link. Okay, I'll copy the repository link and I'll just paste that on my I'll put it in src folder. Okay, cd src, I'll put it in the src folder, git clone, so that all my files will be downloaded into src. Okay, alright, so let me put file structure for this. Okay, so instead of having all files here, what I'll do is I'll simply copy these files. Okay, I'll move these files to here, to the main src folder. Okay, for time being I've just downloaded all this. You can able to okay, so we have all these files. Okay, which is index.html. Index.html is nothing but this is used to display the home page. Let me open with Chrome. Okay, so this is my demo. Okay, so this is my front end. So here there are multiple options. Let me zoom it for you. There are multiple options called home. Home is nothing but the home page. and here we have an option page called add device. When you click on this add device, what we have to do is we have to provide the mobile number of the owner, and when you click on submit, it will send this request to the blockchain smart contract, whatever the smart contract which you have created. So that will get the request, and that request will be stored in the will be processed according to the smart contract function. And when you click on devices list, it will display all the devices list. Okay, and platform test, if you want to test the smart contract, we can able to test it here. So what I'll do is I'll simply connect MetaMask to this website. Okay, but before that we have to create package.json. Okay, so we have to create package.json. So let me create package.json here. So click on new file, package.json. So in this package.json, what we have to do is we have to tell the npm which packages it has to install. So this is a document, JSON document. So we have to write name. So we have to provide some name. So the name is nothing but IoT sensor platform. Okay, something like this. And version, so we have to provide the version. So say 1.0.0. okay, some version. And description of this description, what I'll provide something like the blockchain IoT demo. Okay, and the main one is like it has to run truffle.js. okay, so that is a configuration file. And directories, so the important directories are only two, which is like test directory to test, okay, to test the scripts. But as of now I'm not using any directories. Okay, so here in scripts, so we have scripts available, right? So we have to run the web server. So I'll be using the command called dev. Dev is nothing but development. Okay, so whenever I call this development, which indirectly means that I'm calling a server called light server. So there is a server called light server in npm, which launches the web server. Okay, so I'll write test, so to display if there is any error, echo error. Okay, and exit the server if there is any problem. Okay, and other, so other, say Maddy, license is according to ISC. okay, so you can access this program. Okay, this is given in the description. Okay, so I need light server. Okay, I need light server of any version greater than 2.3.0. okay, so this version is available. Let me run this package.json. To run this package.json, what we have to do is we have to go back and we have to run npm install. Okay, so when you run npm install, immediately this light server will be downloaded and it will be installed in the current directory. Okay, so that we can use this light server to launch the website. Okay, I wanted to run the web server to launch this web pages. Okay, so I have developed some web pages like home, add device, devices list, platform test, and view feed. So these are like front end which I wanted to do. So I'll be launching this through the server. So I'm using light server. So let me also create one more file called the base file, bs-config.json. so this is also a document where I'll be talking about where are the HTML files and where are the contracts. Okay, so here let me open the document. So I wanted to intimate the server. Okay, I wanted to intimate the server where are the base directories. Okay, so here what I'll do, there are two base directories which are needed. One is available in src. okay, in src we have all HTML files and JavaScript files, and also there should be JSON artifact is in build folder. So I'll provide that /build/contract. so in that we have the artifact file called device.json. so in build contracts folder, so this I will be providing in base directory so that the server can able to access those artifact. Okay, now let me run the server. So I have created all JSON documents. Let me run the server, npm run dev. Immediately the server will be launched. Okay, now let us access that server. so which is like localhost colon 3000. Let me open the Google Chrome and let me type localhost colon 3000. Okay, so this is a server homepage which is nothing but our IoT blockchain demo. Now you can able to access this HTML files with the help of server. Okay, now let me connect MetaMask to this website. So now what we have to do is we have to click on MetaMask and it will be showing the wallet. Okay, so this is a wallet which we have imported from Ganache. Now it is showing not connected, which means that it is not connected with this website. Now let me click on connected sites. Let me click on manually connect to current site, so that when you click on next, immediately this MetaMask will be connected with this website. Okay, so that we can able to make some transactions. Now let me add this device. Okay, let me click on add device. Let me provide my mobile number. Okay, 78930156255, and when you click on submit, immediately it sends a request to the MetaMask. Okay, it will send a request to the MetaMask, and the MetaMask, what it will do is it will click, here you'll have confirm and reject. So here we have to click on confirm. So whenever you click on confirm, it is taking some ethers as a transaction fee. Okay, so whenever you click on confirm, immediately this data has to be stored in the smart contract, okay, of the blockchain. So here if you see transaction 4 is confirmed. Now if you go back and check, then block 5 is also created. So block 5 is nothing but contract call. So we made a contract call. So contract call is nothing but function call. So what is a function which we have called? So we have called a function called add device. Okay, so this function, what it will do, it will add this device to the list. Okay, so that it will make it trusted. So let me go back to the platform. Let me click on devices list. Okay, whenever you click on devices list, it has to show what devices have been added. Okay, so here if you see, there is a device address. So this is a device address, and this is the mobile number of the owner. This has been added. So when you click on devices.html or devices list, so what it will do is it will read the data. Then immediately here also we are making a contract call. What is that contract call? Which is nothing but view devices. View devices is nothing but which is getting the data from smart contract, and that data we are displaying here. Okay, so let me click on add device again. I'll import one more account. Okay, so I'll import one more account. Let me go back to the account. Let me go for second one. Okay, so here what I'll do is I'll click on showcase, so that I'll get the private key of second account. So what I'll do is I'll just import this account to the MetaMask. Okay, so I'll add one more account now to show you that account 2. Let me import one more account, which is account 3. Okay, account 3. So let me connect this. Okay, it is not connected. Yeah, it is now connected. Now let me provide another mobile number. Okay, so when I click on submit, then immediately it sends a request to the blockchain through MetaMask, and when you click on confirm, immediately what will happen? So this account will also be stored in the blockchain, right? Now when you click on devices list, then two accounts it has to display. One account with 0x0EDD3, and this is a primary account, first account with my mobile number, and 0xBE7 with the random mobile number which I've taken. So this is nothing but the second account. Okay, which is nothing but the second account here. Okay, so this also have been stored in the blockchain network, right? Now two devices are trusted. So other than these two devices, if you make a transaction, then it will not activate. Okay, so the only devices with these two addresses can able to access the blockchain network now. Okay, because in every smart contract function we are checking whether the device is added or not. Okay, the device is added or not. If that is not added, we are not allowing the program execution. Okay, so in every function, if you see, we have this line, require devices of message.sender, which indirectly means that you are not allowing the execution there. Okay, so let me click on platform test. Okay, so let me enter some humidity value. Okay, some 82.7, temperature I'll give 21.0. okay, something like that. Okay, 21.0, and let me click on submit. So whenever I click on submit, okay, so whenever I click on submit, it will send a request to MetaMask. Okay, and the MetaMask, here you will get confirm and reject. We have to click on confirm. So when you click on confirm, immediately this data will be passed to the smart contract. Okay, in the smart contract we have a function call. Okay, So we have written a function called store feed. Okay, so this function will be called automatically. So this function, this data, humidity data and temperature data is passed. And we have one more page called view feed. View feed is nothing but whenever you click on view feed, you could able to see that. Okay, so let me reload the page. Okay, let me select the first account. Okay, okay, let me pass the values once again. Okay, transaction has been happened and you can able to see the values 82.7 and 21.0. Okay, you could able to see that 82.7 and 21.0. So this is the data which is read for every 5 seconds from the blockchain network. Okay, so again what I'll do is I'll pass one more value. Okay, so instead of 82.7 I'll pass 80.158 and instead of 21.0 I'll pass 22.0. So whenever you click on submit, it will send a request to MetaMask, and the MetaMask you have to click on confirm. So whenever you click on confirm, immediately this transaction will be mined. Okay, mined automatically because we are using local blockchain. And whenever you click on view feed, so the two values has to be displayed. Okay, 80.158 and 22.0. Okay, both values will be displayed. So this is a view feed is nothing but getting the feed from the blockchain network. Okay, now this has been done manually. Okay, so now what we have to do is we have the hardware device, right? Now let us have Python program. Okay, let me create a Python program. Okay, new file, and let me have something like demo.py. Okay, let me have a new file which is like demo.py. Now here make sure that you install. So let me stop the server for a while. What happened? Okay, let me. So this is not responding, so let me stop this. Okay, let me open it again. So let me let me write a program, but before that let me install Web3. Okay, so now Web3 is nothing but the Web3 is nothing but a bridge between, but here in Python script we cannot use MetaMask directly. Okay, so instead of using MetaMask, what I'll do, I'll simply use Web3. Okay, so let me install that. Pip install pip 3.9 install Web3. Okay, 3.9 is nothing but a command which means that that is a version which is available on my laptop. So it says that it is installed. Okay, Web3 is installed. Now we have to write a program related to Web3. Okay, now what we have to do is we have to we have to install one more module called serial. Okay, so install PySerial because we have to read the data from hardware, right? So this has to be installed. Okay, now import serial. Okay, so let me relaunch this, otherwise that package will not be updated. Okay, everything is fine. Import serial. Okay, let me read the data from this serial. Okay, and COM3 is the port number of the hardware, and 115200 is the speed of the communication, timeout equal to 0.5 second, and let me have an infinite loop. Okay, let me read the data, k equal to ser dot read line. Let me decode that value, k dot decode of utf-8, it will encode and it will receive, and let me print the value of k. Okay, so let me have time delay also, import time. Okay, let me have time dot sleep of 4. Okay, so for every 4 seconds it keeps iterating the logic. Now let me run this program. Okay, python space python 3.9, okay, whatever, python 3.9 or python space demo.py. Okay, Acha, it is not com3, it is com9. Okay, so you have to check the hardware. Okay, all right, let me run the program. Now you could able to see the data coming up. So let us wait, because we have given time till 4 seconds, right? Yeah, you can able to see this data. Okay, now what I'll do is I'll simply stop the program. Okay, now here what I'll do is I'll simply check. Okay, if k dot starts with hash, if k is started with hash, then only what I'll do, I'll just print the value of k. Okay, instead of printing k value directly every time, so what I'll do, I'll simply print the value of k only when it is started with hash. Then I could able to see only hash will be printed, hash line will be printed. Okay, Achha, this is not saved. It has to print only the line which is having hash. Okay, you can able to see here. Now what I'll do is I'll simply split this line. Okay, so in Python we have the syntax called dot split, right? So what I'll do is I'll just split the data k dot split of comma. Comma is a differentiator, and let me print the value of k. Okay, let me run the program. If I run this program, what will happen? Your data will be splitted. Okay, so humidity value will be separated and temperature value will be separated. So let us wait for 4 seconds. Yeah, humidity value and temperature value, and let me load the humidity value. Humidity HUM equal to say k of 1, because in first index we have this humidity value, and temp equal to k of 2, right? So we have this humidity and temperature. So let me print humidity and temperature. Okay, so this humidity and temperature we have to upload to smart contract, right? So the smart contract will store the data in the blockchain network. So here let me run the program. So what this program will do, so this program can able to read the data of hardware. Okay, so it will print what is humidity value and temperature value. Okay, so now what we have to do, we have to pass this data to the smart contract. To pass the data to smart contract, we have to import some modules. Okay, from web3 import web3 comma HTTP provider. Okay, since here we cannot use MetaMask, we have to use the server IP URL directly. Okay, what is a blockchain address? If you could remember blockchain address, so let me take one variable. Blockchain address is nothing but http://127.0.0.1:7545. so this is the blockchain address, right? So we have to pass this blockchain address to the HTTP provider. Okay, let me pass that. So here what I'll do, I'll create one object web3 equal to web3 of, we have to provide the HTTP provider of blockchain address. So what is the blockchain address? It is stored in a variable called blockchain underscore address. So we are passing 127.0.0.1:7545, and you need one valid device valid, right? So we have to call web3.eth from ether wallet. Okay, what is the default account? So default account is equal to the wallet of devices. So here we have to take the primary account, because primary account is the wallet address. Okay, so account of 0, so which is nothing but the primary account. Now we have to tell where is this JSON artifact. Okay, so we have to provide the artifact address. So compiled underscore contract underscore path. So we have to provide the contract path. So where it is there? It is there in the build folder. Okay, build folder and contracts folder. So you'll have a JSON, right? Device.json. And also what is it? Contract address, deployed contract address. So what is the deployed contract address? So we have to go back to Ganesh and we have to see what is the contract address. Okay, so this is a contract address, so we have to copy. So every contract which you deploy will have a unique contract address. So we have to copy this contract address and we have to put it here in single quotation. Okay, so this is the contract address. So after getting the contract address from there, okay, so we can able to so we need ABI, application binary interface, also needed. So let me open this artifact with open compile contract path as file, and let me load the JSON. Okay, so contract underscore JSON equal to JSON dot, so let me import a library called JSON. Okay, JSON dot load of file. Okay, we have to load the JSON document and we have to write what is the contract ABI, application binary interface. So if you want to understand this ABI and all that, you please watch the videos in the blockchain playlist. Okay, so contract underscore ABI, contract or JSON of ABI. So we have to load the application binary interface of this contract. So that will be stored in contract underscore ABI. Now here we have to instantiate the contract. Okay, so here contract equal to web3 dot eth dot contract of, we have to provide the address, contact address, so that is nothing but deployed contract address, and we have to pass the ABI equal to contract underscore ABI. So we have to pass the contract underscore ABI. Now here simply what we have to do, so we have instantiated the contract, so we have to call the contract after printing humidity and temperature value. Now we have to make the contract function. So let me have contract dot functions dot, so what is a contract function? We have a function called store feed, if you remember. So you can check out in devices as well. Store feed is nothing but which reads the data, okay, which pushes the data to the IoT blockchain network. Store feed of, we have to pass humidity value and temperature value. Okay, dot transact, so dot transact is nothing which makes a transaction. So whenever you make a transaction, you'll get a hash value, right? So that hash value I wanted to store in tx underscore hash, and we have to wait until this transaction is mined. So web3 dot eth dot wait for transaction received. So we have to wait until this is mined. Okay, so once this is mined, then it means that your data is uploaded. So print sensory feed uploaded to blockchain. So now your sensory data is been uploaded. Okay, let me stop this program, let me play it again, so that you could able to understand that whenever you see account object is not scriptable. Okay, where is that? Yeah, so here accounts. Okay, there are multiple accounts, that's plural. Okay, let me run the program. Okay, what is the problem here? Okay, there is a class str. Okay, acha, fine. Okay, so we have to encode this data. Okay, let me encode it. Dot encode of utf-8. So we have to encode the data. Dot encode of utf-8. Okay, so this was, we have to encode the data. Let me run the program again, so that this sensory data will be uploaded to the blockchain network. Okay, correct. So you could able to see here sensory feed uploaded to blockchain, which indirectly means that your sensory data is uploaded to blockchain network. Okay, let me go back to the platform, let me see whether data can be displayed there or not. Okay, so it is running directly. Okay, let me stop it here. Let me run the command npm run dev. Okay, so now the server will be launched. Okay, and let me reload this file. Okay, now you can able to see the values here 69.00, 29.20. Okay, so Now let me open command prompt. Through command prompt I'll run that Python script. Okay, that is there in src. Okay, alright. Python demo.py. Okay, now this command prompt will be running Python program. Okay, so let me try to compare. Okay, so this Python program will be collecting the data from hardware and pushes the data to blockchain. And this platform, if you see, the values are 69.00, right? So this platform will get reloaded for every 5 seconds, I guess. Okay, so for every 5 seconds gets reloaded, you can able to see here 65.00. So 65.00. So which means that your data is being uploaded to the blockchain network, and that data is downloading onto the platform. So this platform also I have shared in the GitHub repository. Okay, probably you can able to download the same kind of files and you can check it out. Okay, so you can able to see here. So values have been uploaded and you can able to see 69.00. Okay, so 69.00 and the 29.20. Okay, the temperature value is okay. So the yeah, the values are 69.00, 29.20. You can able to check it out. Okay, the values are same. Okay, so here on the command prompt the data has been uploading, and in the on the left side on the platform you could able to see the data is downloading. Okay, so IoT cloud. So generally in IoT cloud we'll be having uploading of sensory data and downloading of sensory data, right? So here also we are pushing the data and we are downloading the data on the platform. Okay, so let me recap what we did so far. So initially what we did, we have connected a sensor with Arduino microcontroller, and Arduino microcontroller we have written a program. So that program have shown you what program I have written, and that program what it is doing, it is collecting the data, humidity data and temperature data, and that data it is passing to Python script. In Python script what we have written, we have written a small logic. We have written a small logic wherein we have collected all the data. Okay, we have collected all the data, humidity and temperature value. So that humidity and temperature value we are passing to a contract function called store feed. So in the in the smart contract we have a function called store feed. Store feed, what arguments it is taking? It is taking humidity value and temperature value of bytes 32. It is not string data type, it is of bytes 32 data type. That is why we have to convert into encoding format. Okay, so we have to encode the humidity value and temperature value, that we have to pass as an arguments. So this humidity and temperature arguments which is written in Python are passed to smart contract function call. Okay, so these arguments are passed to here, and the humidity and temperature what it will do, it is storing in the in the structure. So this structure we have created a structure array called IoT feed, sensory feed, which is nothing but the sensory feed address is nothing but the contract, the memory allocated for sensory feed will be in the contract storage, and the contract storage is nothing but blockchain. So here in the blockchain if you see, the blocks are created. Now block 43, so every sensory feed is been appending to each block. Okay, so we have multiple sensory feeds here coming up continuously because we have written in infinite loop. In infinite loop the continuous sensory data, so the sensory data has been uploading to each and every block, and that block is appending to the ledger. You can able to see on my laptop screen, which is like all the blocks have been added. So each transaction is nothing but one sensory feed, one humidity and one temperature value. Okay, so you could also able to see the device address. Okay, so this is a device address, so this is the sender address which is nothing but device address, and this is the transaction hash. Okay, so this is a transaction hash, this is a device address, and this is a contract address, okay, to which contract is deployed. So whenever the contract is deployed, so contract address will be created, and that contract address you could able to see it here. Okay, so that's all. this is what I wanted to show you. I have uploaded each and everything on my GitHub. Okay, so let me open it. So this program is a bit complicated, that is why let me show you that also, where I have uploaded. So in repositories you'll have storing Sensari feed blockchain. So in this repository I have uploaded all the files. Okay, the package.json which I've created, bsf and config.json, and also I have created some kind of source. Okay, so we have created some HTML files also, so that files also have been uploaded here. Okay, you can go through those files what I have written inside. So that is a small HTML program. Okay, in JS we have written the contract function calls. Okay, in JS will have multiple JavaScript files. In JS folder you'll have multiple JavaScript file. Each JavaScript will be able to make one contract function call. Okay, so app.js, if you look at app.js, it will make a contract function called add device. So app.js, what it will do, it will be calling a function called add device, which means that it is calling the add device contract function. So that this mobile number and account address, device address will be stored in the blockchain account, right? So all that, so each JavaScript file is nothing but with one contract function call. Okay, so data app.js, so data app.js is, it will do one contract function called view devices. So view devices is nothing but this is also a contract function which displays all the devices details. So like this, every JavaScript will be calling one contract function which is loaded in the contract. So these are the multiple files. So I have shared in the repository. You can able to access those files also. Okay, so that's all for now. If you have any questions to ask, you can connect with me on LinkedIn. Okay, or you can join in the Telegram group also. So that's all for now. So if you have any questions in implementing this project, okay, you can reach out to me in Telegram group, or you can also send your questions to my LinkedIn account. So I'm available on LinkedIn. I'm also available on Telegram group. Okay, so thank you for joining me live. If you are watching this video later, so probably you could watch my code repositories also. So the code repository is there in the video description. You can able to access my program. Okay, so thank you. I'll be live. I'll be coming live tomorrow also to discuss about a project on IoT, which is Alexa controlled IoT lamp. So where I'll be creating a skill on Alexa, and I'll be controlling my IoT device through Alexa device. Okay, so I'll be showing that on tomorrow, and on Sunday also I'll be coming live at 6 o'clock to discuss about how to launch a virtual machine on Microsoft Azure. Okay, so there are interesting events coming up. Stay tuned. Please subscribe our YouTube channel, like this video if you like this project. Please always keep doing, keep learning. Thank you. We'll always be in touch if you want to do something unrelated to tech. Okay, thank you all. Stay safe. Good night.